Young people, welcome back. B in the house, taking care of chapter 7, lesson 7, geometric sequences as exponential functions. Okay, so the learning objective, identify and generate geometric sequences. Secondly, relate geometric sequences to exponential functions. All right, guys. So the students will be able to write and determine geometric sequences, as well as understand exponential functions. All right, guys, I'm going to get into this. This one here, guys, I'd like to take it back to elementary. I like to take it back to things you can understand and you feel good about, you know? So hang with me. We got a nice one here. And let's get it started. And just remember our patterns. So, as you can see in the handout, guys, only 18 questions. We got 3 sections. And starting with the first, guys, this takes us back to old school patterns, you know, 2, 4, 6, 8. 5, 10, 15, 20. You know, you didn't know, but you knew eventually. So when they say sequence, you know, 1, 2, 3, 4, 5. Well, it's not 1, 2, 3, 4, 5. It's 7, 13, 19, 25. So what's happening in this sequence? What's happening? You see a pattern. So our patterns are going to go into 2 categories. And I got to pause right now, guys. And the reason why I'm pausing is I know what's happening here. You guys are going to see in a second. If I have a pattern, that means the same thing's happening, right? So as when I say pattern, when I say sequence today, guys, don't think I'm making it hard. I'm saying what you've already known. If it's 0, 5, 10, 15, 20, the pattern is you're adding 5 each time. I can change the pattern to subtracting 5. I can change the pattern to multiplying by 3. I started with 7. The next number is 21. The next number is what? 63, right? Have to do that in the head. So again, guys, we're just talking patterns, but what's interesting today is we're talking about 2 different types of patterns. So when I say geometric, you should think geometry, shapes, geometric shapes, right? When I say arithmetic, arithmetic, yeah, I love hearing my students pronounce it, and I say, don't worry. You never heard somebody say, read, write, and arithmetic, old school, right? So that's all this is, it's meant, arithmetic, right? So the sequence is either going to be based upon, well, let's watch the video because that's how we do, right? We learn by doing. So I'm gonna start the video because I can sit here and talk all day long, right? But let's get it going. What I'm doing, guys, is I'm trying to find the pattern that goes here. I take 13 divided by 7. Right, the second number divided by the first number, the number in front of it. I'm looking for a common occurrence. So, do the next one. 19 divided by 13. Do the next one. 25 divided by 19. Now guys, this is straight in the book. You know, what you're trying to see is, are they the same? Well, guess what? They're not. And since they're not, I can tell you these are not geometric. You're going to see in a second. But what I can see is this. 7 plus 3? Nah. 7 plus 6? Yeah, it's 13. 13 plus 6? Yeah, it's 19. 19 plus 6 is 25. So I do see a pattern. But it's just addition. That's it. That's what I mean by a pattern, right? So when you are just adding or just subtracting and get to the next number, guys, that's arithmetic, right? So easy enough, guys. Well, let's go ahead and state it. There you go. And now for me to explain it, guys, I did it right there in the bottom. Let's see number 2 to see if we catch up on this one here. So negative 48 divided by the original number, and then negative 24 divided by negative 48, and then negative 12 divided by negative 24. So I can kind of see it, guys. So So I would just use my arrows and point it out and what's happening, how I get from negative 96 to negative 48. But look what happens. Oh my goodness. They're all the same because it's geometric. And let me see if I actually show it and write it out here, guys. Am I going to explain it any other way? Because negative 96 divided by negative 48 divided by negative 24 divided by, and of course negative 12 divided by. So I can easily see for number 2, as I'm stating number 1, explaining number 1, we already did it. We're just writing it out here, right? Difference of adding 6. Each number you're adding 6. Now for number 2 though, they have a common ratio of 1/2. Now I say 1/2, but when we were saying it was like divided by 2. Well, guess what? 1 divided by 2, 1/2, right? So we're good and we're going. So for 3, we do the same thing, guys. Take 66 and see what happens when you divide it by 108. Of course, take 144 and see what happens when you divide it by 66. And then take 99 and see what happens when you divide it by 141. Now again, you got a calculator, so it's not like it's challenging you. What's challenging you is the concept and the skill. We're working on that. We're working on understanding what makes the sequence geometric or arithmetic. We got it? There it is. So first one gave us 0.611. The next one is at 0.611 because they have to be the same. And after punching it into my calculator, I say, no, they're not. Wait, then what's going on here? Well, let's figure out what's going on. Because I can do the last one, but if the first 2 don't match, then it doesn't really matter. But showing my work is always good for my teaching and for me. All right? So since none of them match, I'm going to go to my next theory, which is, well, how do I get from 108 to 66 then? Do I add? No. I subtract. And how do I get from 66 to 141? Well, I would have to add. And then from 141 to 99, I would have to subtract, so neither. Neither. So for number 4, and again, guys, you would have to subtract, keeping that pattern, that common arithmetic situation. You know, we're adding 6 each time, we're subtracting 2 each time, or whatnot. So, where are we at? Oh, 4, already on. Little smaller numbers, and of course, what's going to happen when we try to find a common ratio? So, 9 divided by 3, I can do that right off the head. That's 3. 81 divided by 9, well, that's actually 9. And then, of course, I got a calculator, so it's not like I'm going to be challenged. Just go ahead and 6,561 divided by 81 and 81. Now that looks like a pattern, 3, 9, 81, but are they the same? No. So what's happening? How do I get from 3 to 9? It's increasing. So I'm not thinking add 9. 3 plus what gives me 9? 3 plus what? Or 9 plus what? 8. Because I'm looking for a pattern, right? So let's see what's going on. Think about it. 3 plus 6 is equal to 9. Well, 9 plus 6 equals what? Doesn't equal 81. 81 plus 6 sure ain't gonna equal 6,561. So again, guys, I'm going with neither. And it's okay because something's going on, of course, but it's not the geometric sequence or pattern that you're looking for. No big deal, I'm not gonna let the fraction scare me. For number 5, 7/3. So 14 divided by 7/3, what do I get? I'm gonna try to do it right now. Okay. 84 divided by 14, and of course the last one will be 504 divided by 84. Again, just trying to find if there is a common ratio. Meaning, will they all equal the same thing? A little fun here, right? Get 6, and you get 6 again. And of course, that one, I'm sure you know you're gonna get 6 again. So they check, I'm okay saying this is geometric, and with a common ratio of, you got it, 6. And since it's not 1/6, that's why you would multiply, right? 7/3 times 6, 14 times 6, 84 times 6, and that's how we would get our next sequence of numbers. Last one looks like number 6. 1/8, and gotta love a fraction divided by a fraction. And again, guys, no, I don't remember this. 1/8 divided by 3/8 becomes 1/8 times 8/3. So 1 times 8 is 8. 8 times 3 is 8/24. Which again simplifies to 1/3. So now I'm hoping to get 1/3 for all the others. And again, I just got a whole lot more to do, right? So hopefully I will speed this up because that's a lot of fun, right? 5/8 divided by 1/8. And again, remember this? 5/8. Are we gonna do it again? Come on, we gotta do it again. You know you wanna see it again. I wanna see it again. 5/8 divided by 1/8 becomes 5/8 times 8 ones. I cross simplify here. 40 over 8 is 5. They don't match. So since they don't match, I can stop right there. I don't like it. But I do recognize with 6 that I have a common denominator. And then I look at my numerators and I kind of go, hold on. 3, -1, -5, -9. Seems like they're going down. So let's see what happens here. Can I find a pattern? 3 plus what? 3 plus what? 3/8 plus what equals -1/8? -1/8 plus what equals, my next one, -5/8. Then of course, right, the last one? Yeah. -5/8 plus what is equal to -9/8. So it has to be the same thing in each one of those, right? So can you figure out the first one? I can figure out the second one. -1 minus 4, right? So they all should be -4 for my numerator, and it looks like it is. So yes, or not yes, we got it. So we're gonna get this out of here, I hope. Part 1, again, when I started, guys, they're just patterns. Are there patterns that are using addition or subtraction, or patterns that are using multiplication and division, right? And that's where the common ratio or a common difference is what we were looking for. Now for the second component, find the next 3 terms in each geometric sequence. So they're telling me it's geometric. So automatically my brain's starting to already move to that multiply and divide situation. For 7, I'm starting with a big number, 2,500, and then it gets smaller and smaller. So I think I'm dividing. Now the choice would be, what would I divide by? So here is where I recognize division and divide by 2. Divide by, look at that. Have you got it yet, guys? 2,500 divided by 5. Oh, I want to show it. So this is going to tell me, right? This is what we did earlier on. 500 divided by 2,500, 100 divided by 500, and it should give you the same thing, right? 1/5. And over here, same thing, 1/5. So literally, divide by 5. Right? So, your answer is 5, and of course, I saw it. 2,500 divided by 5 gave me 500. 500 divided by 5 gave me 100. So next, 100 divided by 5. There you go. Put it in your calculator, you get the next number. Boom. 20 divided by 5. Put it in your calculator, get the next number. Boom. And of course, 4 divided by 5, you put that in your calculator, you can't write it as 4/5. But 4/5 is good enough for me. Box all 3, or box each one individually. So I showed it, I got it, I think it's good. Let's move on to our next one, number 8. So for 8, I see the number is a little bigger. 2, 6, 18. So my brain is thinking multiply, of course. We multiply by that. Well, let's use that little technique. Find our common ratio. 6 divided by 2, easy enough. 18 divided by 6, easy enough. So it looks to me that my pattern is to multiply by 3. And you might have saw that already, guys, and when we started the video, you know I talked about we're going back to elementary patterns, right? So 2, 6, 18. 18 times 3, 54. Ooh, I think I did that in my head. 24 plus 30, 54. 54 times 3, 150 plus 12, 162. And don't ask me, 162 times 3 is 300 plus, I don't know, y'all. No, 486. Got it. All right, nothing's changing, guys. They're throwing a negative in here, but that's not going to change how I process this. I'm a negative 4, and the next number is positive 24. The next number is a negative 144. Hold up, wait a minute. Is it getting bigger or smaller? Oh, it's dealing with an integer. Got it. Well, let's see what's happening here. Negative 4 became 24, so it definitely got bigger. Multiply. So what number times negative 4 can give me 24? I don't know. I do know, you know too. Negative 6. But let's check the pattern. Negative 144 divided by 24. And here, guys, you popped it into a calculator, or you wrote out your what is it? Expanded notation. You know, just cancel things in the top and bottom. But you see you get negative 6. So, literally, that's why it goes from negative to positive to negative to positive to negative to positive, because negative times a negative will give me a positive 24. Now, a positive 24 times a negative 6, it's going to give you a negative 144. So, recognizing that alone kind of helps me in knowing why it did what it did. And knowing that, okay, the next number needs to be negative. Okay, and then the next number needs to be positive. So, having an understanding of your integer rules, right? Negative times a negative, same sign. Positive times a negative, different signs. And knowing what to do when that happens. Hey, there's one big, you know what I'm doing. All right, guys, if that's true, let's see if we can get 10, 11, and 12 right. If I know what I'm doing. Again, guys, just making sure you are catching the concept. I don't want to make things seem more difficult. You literally figuring out how to get to the next number, either by multiplying, dividing, adding, and subtracting, right? And of course, knowing that it's geometric, that's because you multiply and divide. And of course, we're ready. 10. Finding my common ratio. So going right into it, 2/5 divided by 4/5. And again, I love to show some dividing fractions, right? Boom, boom, pow, hey, ding, dong. Love it. 1/2 or 10/20, right? But we gotta make sure that's for the next one, and hopefully it is. And once I do recognize that that's my common ratio, I can use that to get the next 3 numbers in the sequence. So, I'm looking good so far. Why not? I don't know why I think that 1 times 5 was 10. I knew the bottom was 10, but there we go, guys. So, are those the same? Yes, they are. If I multiply the numerator by 2, I get 10, which you see me doing. If I multiply the denominator by 2, I get 20. So, a common fraction, right? Equivalent fraction, I apologize. Now that I know 4/5 times, and this is what I'm going to use. I'm going to use 10/20. I could simplify 10/20, but whatever. Boom. Do I get the next value? It's working. It's working. Let's do it again. Now 2/5 times 10/20. And don't say nothing. I know it could be 1/2, but it's keeping things 1, 2, 3, ABC. Oh, I guess not, 1/2. So top times top gives you 2, bottom times bottom is gonna give you 10. But 2/10 is the same as, 1/5. So check. Well, now I can keep going, do that same thing. 1/5, bring it on down, times 1/2, top times top, bottom times bottom, write it in, 1/10. Do it again, I gotta do 3, right? So now 1/10 times 1/2, top times top, bottom times bottom. Boom, 1/20th. And of course, one more time for good measure, right? 1/20th, and I'll put it right up here. 1/20th times 1/2, again, 1/40th. So, again, guys, recognizing the skill that you're using, we're using multiple skills right now, guys, but we are focusing on writing sequences, right? Geometric arithmetic. Where we at? What we got? We're done, right? No, we're not done because we've only done the top portion. In the middle portion, we got 2 more, 13 and 14. So I'm looking at 4 times 4. Yep, times 4. Yep. So 48 times 4. Boom. -192 times 4. Boom. And neatness counts. Boom. So guys, of course, after doing handout after handout after handout, you might get a little sloppy in your writing, but never let it prevent you from doing your best work. Oh man, 72 divided by 6, 12 divided by 6, 2 divided by 6, well, literally 2 divided by 6, 1/3. Get it in there. Next one, 1/3 divided by 6. So make it a fraction, flip it, 1/3 times 6 ones. Yes, 6 ones. I need you to flip it, right to reciprocal. You know, I just said that wrong. I did it right here. I just said it wrong. So 1/3 times 1/6 is going to take your reciprocal of 6. You flipped it. There we go. So, I need one more number. And we're doing the same thing, guys, this time. I'm not gonna say a word. All right, guys. You know, sometimes we have 9 of the same problem. You're here to get help. If you can understand it after 1, and you're checking the other 8, whatever works for you guys. Bottom half. It's like I would like to figure out how to write an equation for the nth term of a geometric sequence. I remember this one, guys. So I pulled this in because why not? Having something to assist you is going to make it so much easier. So breaking this down, you have the variable a, first term of the sequence. Of course, r is the common ratio. So right now, I'm trying to find my common ratio. I'm going ahead and doing -24 divided by 3, of course, 192 divided by -24, and it points out straight ahead I got my common ratio. So I can tell you what r equals. Excellent, and help me in with filling in the formula that I'm looking for, at least for 13. So, common ratio is -8. What else do I need? The first term, of course. And the nth term of the sequence, right? Now, 13, so I have to circle, I have to clarify for myself. Number 13, there's our formula we're going to use. We already know a to the nth term, right? It's equal to 3 times -8. Where did the 3 come from? First term of the sequence. Where did the -8 come from? Common ratio. Now I've got n minus 1 as my exponent. Well, that's fine, guys. So think about it. That right there, we're done. There's your equation. Now, whether you want to know the first number, the second number, the third number, the fourth number, the fifth number, that's what we need by where an is equal to the nth term of the sequence. So, what do we know? We know this, guys. You see how I got the 9 minus 1? Because I want to know the 9th number. So, put in 9. 9 minus 1 is 8. 3 times negative 8 to the 8th power. Well, guess what? 3 times a big number. I think I need, that don't even look right, y'all. That comma's in the wrong place, I probably, yeah. Check the calculator, right? But easy enough though, guys. I now have the 9th number. So, right here where I got A with the little n at the bottom, remember that little n is 9. It's the 9th number in the sequence. Yes. So, we gotta do that enough times that hopefully it's gonna make sense to you, right? So again, 14, what do I need? I need to know the common ratio. I need to know the first number in the sequence. And I also need to know what number in the sequence you're looking for. So for 14, looks like a fraction divided by a fraction. 3/8 divided by 9/16. And the second one, of course, 1/4 divided by 3/8. So, showing a little magic here. It's not magic, it's just dividing fractions. 3/8 divided by 9/16 becomes 3/8 times 16/9. I can cross simplify. The 8 will be 1, the 16 will be 2. The 3 will be 1, and the 9 will be 3. So, I'm going to get 1 times 2 is my numerator, and 1 times 3 is my denominator. In other words, 2/3. Now, my next one needs to be 2/3, and we should be able to pluck it out just as fast. 1/4 divided by 3/8. Go ahead and rewrite the first, change the division to multiplication, and take the reciprocal of the second fraction. 1/4 times 8/3. Cross simplifying. And again, looking good to me. I got 2/3 once again. So that is twice. We got common ratio, 2/3. What else did we need to know? That's what R is equal to. What else do we need to know? You know, it shouldn't really box that unless it's your answer, but it's okay. We're gonna be using it. Oh my goodness, looks like I need something. I need what I had before. So guys, I did this on purpose. I want you to know I am using the internet just like you are. So go get those formulas, whether they're from a book, whether they're from the internet, whether they're from some, old book grandpa gave you. Who cares, right? Math hasn't changed for a million years, y'all. Well, Common Core tried to change it, and it helped us out a little bit. Didn't help everybody, but math is math. So, there's your formula. There we go. Plug it in our initial first number in the sequence. Plug it in our common ratio. And now here, guys, n minus 1 again. So there's my equation, but now I need to know what number are we talking about, all right? You want to find the first number? We'll just put in 1. 1 times, 1 minus 1 gives 0, with 0 power, but we'll talk about that next one. What value did they want for 14? What value? What number in the sequence? The 7th, so 7 minus 1. 7 minus 1. Third time's a charm. 7 minus 1. So again, guys, I keep saying A in down there, but A, 7, the 7th number in the sequence. All right. Go ahead and the 6th power. So 2 to the 6 and 3 to the 6, right? 2 to the 6 all divided by 3 to the 6. And again, without a calculator, you might struggle a little bit, so don't put yourself in that situation. Have faith that you're okay. You do know what you have to do. You just gotta get it done. So, keeping it, hey, just like I said it, right? You know how my brain works. But we got more we gotta do, and we gotta finish her up. So, right here, guys, how am I gonna handle this? Well, 3 times 3 is what 9 is. And guess what? 16 is 2 times 2 times 2 times 2. I'm doing expanded notation, right? I can break down 2 to the 6 by saying 2 times 2 times 2 times 2 times 2. I don't know if I said it with 2s, but 3 times 3 times 3 times 3 times 3 times 3. And now, guys, we just get to canceling. That's one way to do it. Do it that way. And I hope everything cancels. I got a lot to worry about. 3 times 3 times 3 times 3. 81. And there it is, guys. And I'm okay with that. I like it. Of course, I'm verifying with my instructor. And maybe even checking the odds in the back of the book. Whatever you need to do, guys. But 100%, not enough. Let's get some more in. You're lucky I do all 18, right? But let's get it. 15. Well, I guess you ain't lucky. Hey guys, I really enjoyed being here. We always have a good time.